Hello everyone, welcome to my YouTube channel. And today our topic is EIGRP packet flow. Okay, basically there are five packets in EIGRP. There are hello packets, update packets, query packets, reply packets, and acknowledgement packet. Okay, if I talk about the hello packet is used to discover and maintain the neighbor relationship. Okay, and update packet is used to propagate the routing information, and the query packet is used to request the routing information from other neighbors, right? If any if any link is down and the neighbor is unreachable, so the query packet will be forwarded to the other neighbor to find the alternate path. Okay, a reply packet is used to respond over the query packet, and on response of hello and update packet, the acknowledgement packet will be forwarded. Okay, so let's discuss about all of these packets. Okay. If I talk about the hello packet, so hello packet is forwarded with a multicast address 224.0.0.10 that is reserved for the EIGRP protocol. Okay. Let us assume the hello packet has been forwarded to the neighbor, and it in every 5 seconds the hello packet will be repeated to check the neighbor connectivity. Okay. When the hello packet will be forwarded to the neighbors, in after that the neighbor table will be formed. Okay, and this is what the hello packet has been forwarded. The destination of this hello packet is 224.0.0.10. Okay, after that the neighbor table will be created. To check the neighbor table, there is a command show IP EIGRP neighbors. This command is used to check the neighbor table. Okay. After when both the routers get the hello packet, then they will form neighborship and the update message will be forwarded. This is called update packet, and this will be forwarded to forward the routing information to exchange routing information between the routers. So after hello packet, just after hello packet, the update packet will be forwarded to forward the routing information. Okay, and this update packet also forwarded to share the incremental updates in the EIGRP protocol, and the topology table will be updated by the help of what? This update packet. Okay, so to check the EIGRP topology table, the command used is show IP EIGRP topology. Okay, so this is how the update packet has been forwarded that will share the routing information. After that, when the update packets will be received, the routers will share the acknowledgement packet. Yes, the data has been received by the by the router. So when the update message will be forwarded, in response of that, the acknowledgement message will be received. Okay. Now the next packet is query packet. Okay. Let us let us assume we have three routers in our network. Okay. And this network is down by mistake and or disconnected and not responding. When any link is down, the router will multicast a query message to all the EIGRP neighbor. That is there any another path available to communicate with R3, right? In response of that, the reply message will be forwarded that there is no path, or there is another alternate path that can be used to forward the data to R3. Well, both of these possibility can be there. Okay, so this packet is used will be forwarded to the source again, because R2 has forwarded the query message that is there any alternate path available. In response of that, router has forwarded the reply message no or yes. Okay, if I talk about the practical session, so let's observe all of these practically. Okay, so dear, this is our network on which some routers are there. Three routers are there, and we have just mentioned the IP address is 192.168.10.1, 10.3, 11.1, and 11.2. Okay, two networks are available here. So now we are going to configure these. Okay, so I'm clicking when you will right click on the link and click on start capture, the Wireshark will be started in background. Okay, it will show you the packet flow in between the two routers. Okay, so I'm capturing the packet in between these two. Okay, Let's start doing the configuration from R1. First of all, we will provide the IP address. Okay. Configuring terminal. Okay. Interface F0/0. No shutdown. No shutdown. IP address is 192.168.10.1 and 255.255.255.0. Okay. Let's provide the IP address to router 2 configuring terminal interface F0/0. No shutdown. IP address is 192.168.10.2 and 255.255.255.0. Next interface is interface F0/1. No shutdown. IP address is 192.168.11.1 and 255.255.255.0. Okay. If I talk about the last router has an IP address 192.168.11.2. Let's provide this IP address also. So go to router 3 and global configuration mode, put a command interface F0/1. No shutdown. IP address is 192.168.11.2 and 255.255.255.0. So we have just allotted the IP address. Okay. Now we are going to advertise the network by the help of EIGRP protocol. So how we can do that? Router EIGRP1. Okay. Network 192.168.10.0. Whenever I will advertise the network, the hello packet will be started forwarding in between the routers here. Okay. You can see after every 5 seconds, the hello packet will be multicasted in between the routers. Okay. New messages has been forwarded. So this is how the multicast message will be continuously forwarded to the neighbors. Okay. In every 5 seconds, because this is fast Ethernet cable. In fast Ethernet cable, the time is 5 seconds to forward the data, forward the hello packet. Okay. Whenever I will also configure the EIGRP protocol on the neighbor R2, the R2 will also forward the same packet. So router EIGRP1 network 192.168.10.0. Whenever I will advertise this network and router EIGRP1 network 192.168. Okay. So whenever I will advertise this network 192.168.10.0, you can see that the hello packet will also be forwarded from the 192.168.10.2. So that is means both of these routers are multicasting the hello packets like this. So R1 is forwarding the hello packet to R2, R2 is forwarding the hello packet to R1. When both the packets will receive the hello packet, now the update message will be forwarded in response of hello packet like this. And the update message includes the routing information. Here you can see the update message has been forwarded. That is means neighborship already been created and now the routing information is being shared in between the routers. Okay. When this packet will be received, when the update packet will be received, to the routers, the acknowledgement packet will be forwarded. So in response of this packet, the routers will forward the acknowledgement packet. Yes, we have received your update message. So here you can see that the update message, the reply message, the acknowledgement message is available here. Now the question is that when will be the query message and reply message will be forwarded. First of all, let's configure the routing EIGRP on R2 and R3. On R2, we will also advertise the network 192.168.11.0. Okay. On R3, let's also advertise the network. Okay. Router EIGRP1 network 192.168.11.2 and 255.2 network 192.168.11.0. Okay. Now, the adjacency has been created in between all of these, and the routing table will also be created in between them. If I will go to router 1 and put a command show IP route, it will show me the routing table. So this is the routing table available on which the best path and the directly connected network information are available here. Okay. By putting the command show IP EIGRP topology, you will get the information of all the routers connected in this network. Okay. By putting the command show IP EIGRP neighbor, you can see the neighbor information of the routers. Okay. Now, what I'm going to do, I'm just going to turn off this link R2 to R3. I'm going to disconnect this link. The router will not able to forward any data to router 3. In this time, the router 2 will forward a multicast message to router number 1. What is that multicast message? That multicast message will be query message with 224.0.0.10 at the address. The meaning of this query message is that is there any other path available to communicate to R3? Okay. In response of that, the R1 will forward a message, no, there is no path available. It will either forward yes or either forward no. So in response of that, in response of query message, the reply message will be forwarded. Okay. So let's observe this practically also. So let me disconnect this link. First of all, I will go to router to select the interface F0/1 and shut down. Let me shut down this link. Now, no information can be forwarded from R2 to R3. Okay. Now, you can see in the end, the query message has been forwarded. Where is the query message there? Here you can see the query message will be forwarded in between these two. Here is the query message. This one is query message that will be forwarded or multicasted to all the routers to check the alternate path to forward the data. In response of this query message, the reply message will be forwarded that there is no or yes any path is there to forward the data. Okay. So what we have seen, the R2 cannot able to forward the data to R3 because this link is down. So R2 has forwarded a query message that is there any alternate path available for the R3, but there is no alternate path. So R1 has responded to that message that no, there is no path available for the same. Okay. So this is how the communication or the packet flow works in case of EIGRP. So if you have any query regarding that, please ask me in the comments and have a nice day. And please subscribe the channel also.